So tomorrow's Thanksgiving. I want to give thanks to all of you guys putting up the Algos in 10 season 2. And also I also want to talk about giving thanks before the episode begins. I agree, under this pandemic, things have been rough, things have been challenging, but I really am blessed to still be able to safely do all this at home, be able to still be with my friends and family during Thanksgiving, and to learn that nothing is always bad or good. It's always a mixed bag. So just like the turkey that some of us will eat tomorrow, let's learn to just simply, cut down the problems into different pieces, drumsticks, wings, wishbones. Without further ado, here's the season finale for Algos in 10 season 2 Jason Loop. And by the way, if you've not yet subscribed or liked, now's your sort of last chance to do that. So there'll be no slide deck for the season finale, and there'll actually be an extra bonus content called web crawler. That's right, I'm actually going to mention a little bit of web dev for the season finale because that's actually one of my favorite computer science topics as well. Actually, relates quite nicely to what I've been doing to prepare for the coding portion. I'll give you a fair warning, this coding portion took me a significant amount of time, probably the most time I've spent on any Python notebook outside my Northeastern final project. For it is basically a parody of that. And I was going to share my screen to show you why. So as you can see here, this is the final project, parody. So it's called Apriori classification and analysis. So the first thing I did over here is I pre-processed the data set by installing some executables, INB learn, which is basically for some learning algorithms, MXL extend for a priori FP growth, and then APYORI for a priori itself. And you can see there's a lot of imports, like 50 something imports, but it's a pretty insane number. But it's a finale, go big or go home. I also do a lot of commenting as well, as you see. And a lot of throwback, like episode 8 from the Teen Titans. So without further ado, here's what I do for pre-processing. I first pre-process the CSV by reading it. Then I fill the NA. I make a copy of the data set. Now, why do I do that? Well, let's say I screw up something later down the road. I need a backup, right? Just like if you end up, dropping your turkey, your left turkey wing, you need a right turkey wing to eat, or you're going to end up having no turkey wings on Thanksgiving. And then remove some unnecessary features, which is essentially all the features that are not numbers in this case. Because you can't really apply a priori to personal travel or male, female, those are sort of predetermined binary features. So we got rid of all the features we don't want, and look at that, so much nicer, just 7 features in general. And of course, we check the mainframe again, check the data frame again for NA values. Next is Smoky. So yes, I've talked about Smoky in a previous episode. It's basically trying to address imbalanced classification. So for example, I have a lot of data over here. I'm gonna annotate quickly. I have a lot of data over here. That it's dot, 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 dot. And then basically very, very small amount of data over here, dot, 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 dot. What Smoky does is split it into 2. We have all the red data sets here and the green data sets here. It's almost like splitting the data sets into 50-50. Not quite, but very, very close. So anyway, I apply Smoky here. So before I apply Smoky, I need to make a target, right? This is a prediction. This is a classification prediction model. So I need to make a target be the cleanliness. The reason why I chose target to be cleanliness is because this is the only model that is independent from the others. As you can see here, there's no value of 0 at all, which means there's absolute independence from the other models. So apply Smoky here. We basically remove the value counts, and then look at that. Smoky makes everything balanced. You then do XY because you want to basically have XY data set. Apply min max scale for Smoky here, and you basically split the data set into a 70-30 ratio because that's a train test model. And you basically print the shapes, and finally apply Smoky. And I love this particular function. is it shows you that Smoky works. It's like all this dissatisfied rating and these satisfied ratings can be balanced out. So after Smoky, it actually becomes balanced out. Same thing holds with random undersampling, which is a little bit different than Smoky. For random undersampling, it's more like this. You have another data set. You have now some dots over here, right? And you have some dots sort of being random around over here. And instead of splitting it half and half this time, what random undersampling is, it moves all of the data sets in one distribution, it moves a data set on the other distribution, and then in the middle is basically just a bunch of other like blue or red points in the data set. So it's very easy to get confused between Smoky and random undersampling. And this gets into a little bit of probability. So basically the probability that you have blue or red in random undersampling, in this case, is going to be greater than or equal to 1/2. And why do you know this? Because of the Bernoulli principle, binary probability. So per probability flexing aside, it just shows you right there how important it is to like actually know what type of sampling you're using before you use your data set. So this is a naive rebalancing. It's not like an algorithm. It's just like basically putting one side to the left, one side to the right. And we'll use the three main classifiers of decision tree, logistic regression, and gradient boosting. We want to get AUC value greater than 0.7. And to make sure there's no bias, we basically remove the duplicates by saying diaphragm dot drop duplicates. So here we go. We basically have removing everything that's not the target here in the NA. This is a bad idea, but I just want to show that it works. I normally do not recommend hard coding sample values, but this is just a demonstration. We apply random undersampling here and look at that. It's like that before, but you can see it's switched, right? The dissatisfied and satisfied switched this time. So now satisfied is actually going to now become the minority class, and dissatisfied has become the majority class. If I were to give a quiz tonight for Algos intent, I would ask you, what is the majority minority class? And you'd probably answer to me, okay, Jason, this means that you want to basically say that the data set with the most points is the majority class, the least points is the minority class, and you'd be wrong, because it's basically saying the data set with the most distribution is the majority class, the least distribution is the minority class. And we talk about the models. So decision tree classifier. Basically fit it, you predict it, you get the tree depth. And then I use a tree because it's very easy to like know what's the optimal by using tree depth. So finding scores. And we run the tree depth curve over here all the way over to the end. And it basically tells me the tree depth with the highest test score, because you want to see how accurate your model is the tree depth of 3. And then I have a very awesome helper function called the swing metrics, which basically tells you all the values of each model metric, like the test score, precision, recall. So you can see this finale episode is basically putting everything together we've learned so far and put into one like gigantic project. And yes, I'll give you guys fair warning. I did not pre-sample this data set. So AUC is going to be pretty crappy. It's going to be 0.5 and 0.65. Logistic regression gets a little bit better, especially with linear regression coefficients. It gets actually a lot better. It's 0.65, which is almost very close to 0.7. So check here. Check here. And also the logistic regression for the accuracy precision, basically the precision recall is also very, very good. So I'm going to give a check here as well. So yes, that's very great. And then, whoops, I should not say that. Anyways, the final model is going to be gradient boosting, and that's very important because you want to like basically have a gradient boosting to get the feature importance. Now, gradient boosting gets a little complicated, so I'll make it very simple this time. The estimator is how many times you're running the model. The learning rate is how many times you want to learn the model. Max step is, of course, recursion tree, how much you want the model to go to. And random state is more like just how many times are you going to randomly use k-fold on a model. Once again, use display metrics and gradient boosting, and not so good. It's okay, it's passable. Like this is passable, this is not that good. So we can already see, based on just applying the model, logistic regression is clearly the winner. But we're not done yet. We have to now apply a priori. And this is where it gets into a bit of, you know the joke when things go bad, they call it the turkey of the day, quote unquote, bad Thanksgiving pun. This turned out to be the turkey of the entire project. Because I applied a priori, I removed all the NA, and look at this. I get absolutely nothing for association rules because you can't even associate with numbers at all. So a priori was basically an epic fail. So I'm sorry, but this project showed me a priori is not the way to go. However, all is not lost. FP growth was way, way better. But FP growth is why you talked about the MLX10, right? To do a transaction encoder. And here's how transaction encoder sort of works. Let's say you have a data set here. And you have, for example, L, R, L, R, L, L. And let's say this is basically like your directions for your driving or something. You turn left, you turn right, you turn left, turn right, turn left, turn left. What the transaction encoder sort of does, it makes a mapping between each letter and each number set. So I have a mapping of basically binary, 0 and 1. It's very similar to the one-hot encoding, except it's with any type of mapping. So for example, I can also do transaction encoder with other letters like D for down or U up. And that will also somehow map to a different data set. So long story short, the one-hot encoding is basically a one-to-one mapping. Transaction encoder could be many-to-one mapping. So the transaction encoder ties in very nicely with the frequency table, which is very important for FP growth. And you get a frequency table over here, and you finally get a good-looking support value and item sets, which are in tuples. And of course, the item sets again using min support 0.6. Finally, we get to the fun part, ROC curves and predictive labels. And don't worry, I'll put this all on my GitHub so you can actually take a nice good look at it and not think I'm BSing you with my results. I am an honest person, so this is not like the tech lead. Not that I'm actually going to slander any of the YouTubers, but this is actually not like the tech lead. I am going to be honest with my intentions here. Okay, I'm not going to use ingenuity or cunning or deception before Thanksgiving. We're here to give thanks to computer science models, not insulting others. So little anti-rant aside, you can make some predictive labels and ROC curves and plots here. So basically you have two parts. You have the Smoky and random undersampling. You apply the model logistic regression and gradient boosting classification. And you do it twice. So why do you want to do it twice? Because one reason. You want to do each for Smoky and random. And this will print out literally the AUC values for those. And once again, since I did not do enough processing for those remaining features, we're just going to have to hope that everything's above 0.5. So right now, not looking good for this entry, though AP is looking a little bit better for the precision recall. Display metrics, not a whole lot better here either. Logistic, ooh, surprisingly not doing that great anymore because we're actually now applying both Smoky and random. Logistic again, same here. But wait a minute, gradient boosting, okay, not bad. And gradient boosting actually turned out to be the best because consistently both of these models have 0.65 precision recall. Finally, we apply some heat maps to the modeling portion. So heat maps are not normally common, but do help you, like filter down some more features because you want to avoid the curse of dimensionality. So you want to basically print all the columns, apply the heat map. It looks very crazy, but you can see where I'm trying to go with this. Basically, any two heat maps that are correlated become an XY plot. And this is a really crazy case of heat map because with regards to temperature delay in minutes for my data set, for the Priori data set, it doesn't work too well. It's basically a black box, and you don't want a black box in data science. And same thing with heat map 7. So 6 and 7 are out. Finally, we have only 5 features to compare. Seat comfort, departure, arrival, time convenient, food and drink, onboard service, legroom service. And finally, we have making some predictive labels and plots for clustering. So this is very important. We don't use GMM over here because it's not good for classification. Much rather use principal component analysis or SVD, support vector dimension, or singular value decomposition. Use that instead. And then finally, make it basically like a tier meme or a tier rank here. So we essentially make 5 clusters without blobs. And here's the interesting part. These clusters aren't really clusters because you have so many data points similar. They're almost like a matrix, right? This we call a degenerate cluster. It's not a bad cluster. It's just a different one. So you can see already from the clustering, there's almost no universally bad correlation between 2 of them, but it's sort of almost random. And because they correlate so well, it's called uniform. It's called uniform or degenerate cluster. And finally, we do the thing we love the most, ranking everything. Like ESPN Power Rankings, basically rank every feature. And I'll have to actually give shout out to my man, Jason Brownlee here from Brown, because he has a fantastic website called machinelearningmastery.com. It's all named Jason, which is great to know there's another computer science, data science guy named Jason doing the good work like this. Very, very, very nice. To basically conclude the episode in terms of this portion, that is, and Algos intend with data science mixer by basically determining the feature rankings as follows. The first feature that wins is seat comfort. The first feature wins is onboard service. The second is departure, arrival, time convenient. Third is seat comfort, and fourth is food and drink. And now there's some final remarks I'm going to make. So obviously, if I had more time, like an actual semester project, I spend more time pre-processing stuff and doing more classifiers. Obviously, I don't have that much time. And to quote the meme, I don't have time for that. So it is very tough to actually put all the classifiers in the world. It's sort of like the old chicken and egg joke. Which came first, the classifiers or pre-processing? And the answer is you won't have a good classifier if you don't pre-process your data. And if you fail to pre-process your data, you will not have a good classifier. So do pre-processing and then classifier. Of course, that could also clean up the data more rigorously, though I think NAN has done actually enough for at least demonstration. And yeah, Apriori turned to be a poor design choice, which unfortunately defeated the purpose of using Apriori in previous episode, but the FP growth saved the day. It made it much more interesting. And then maybe this is just a reminder that this thing is just scratching the surface of what we can do. So we can't put entire exploratory analysis of classification in just one episode or however long this thing will last. So now I'm gonna get to more fun parts. We're gonna talk about web crawling. So here's the Selenium web crawler. If you've never used Selenium before, it's actually quite beautiful. It is, of course, with the module Beautiful Soup. So to install Selenium, we do the same thing with the executable. We basically import an OS path, and we do for basically Chrome. So I'm going to run this thing cell by cell. So first, we basically open Chrome. So we have Chrome, right? It can web crawl. So if I do inspect over here, I can web crawl all the Google website. I can web crawl, for example, the Google logo, the Google search engine, and everything. And of course, it only gives me 10 seconds to look at it because I made sleep 10. That's fine. That's enough to at least know what Chrome looks like. You could also use it with Firefox, but I didn't exactly enable Firefox for my thing. And of course, it says over here, Chrome is being controlled by automated test software. So you can't use it like hack Chrome or anything. Just use it for web crawling and legal purposes only. Please use Algos intent ethically here. And now we're talking about web crawling using Beautiful Soup and results. So we basically import Beautiful Soup. And this is from the Expedia web scraper. So we have the web crawler being initialized. We have a def download page, downloading hotel page, and then finding basically 4 main features: the hotel name, address, title, about. It's also work for Airbnb, but I think rather hotels are more useful to tell you what's going on. So as you can see, the results are quite nice. It gives you a nice legible name, Holiday Inn Express, and Suites Lexington Park, California, an AIH hotel. And of course, gives you the title, the about, and the address for each of the hotels. And this is simply scratching service you can do for a web crawler. The web crawler is very efficient for any type of display you wish to use for data science, web design, and analytical project. And now, since I did mention this is going to be a two-parter finale in regards to crawler, here's the Java. Here's his cousin, Java. So this is Eclipse. Before I discuss the code, let me tell you something. I am not a huge fan of Eclipse. It's hard to use the server. It's hard to install. And it's a PIA. It really is. I must say, Eclipse, for the first time, told me the perils of not using modules correctly. That being said, compared to IntelliJ, Eclipse is much more novice friendly if you don't know how to put your code together. So I have, the quintessential source and test file over here. They have a source Selenium package, which has an interface called iSpiderLeg. And I, of course, give my FSC and PDP Northeastern course credit, and even my Dell coding some credit for basically some proper mainframe structuring. So I have 4 methods. I have crawl, search for word, get all links, and get all queued. I then also have a Selenium browser website or Selenium browser Java class that lets you print the properties, basically talking about the properties of web crawler. And you can set the property as well to be a Chrome driver. What's interesting is here, the spider crawler. So this is related to Apriori because it's sort of applying Apriori, basically getting a bunch of data results and trying to create a pattern of it, right? Sort of like a frequent data mining thing. So I have basically all the different fields using some hash sets and linked lists and array lists. So to make everything run O1 space, I have a method for getting the next URL. And of course, this will also be on my GitHub as well. So all this code, including the entire repo basically, is going to be based on tonight's episode. So yeah, I do some defensive checks here. If URL equals empty and search word equals empty, you cannot return any search string that's basically false. Otherwise, if you search everything, you run out of options. You basically no more pages to visit. Otherwise, you keep on searching. And of course, I have a Boolean variable here to determine if I actually found a word in a search. And that completes my web crawler. And finally, the spider leg. So here's a nice little animal joke. Why is this thing called a spider? Well, hopefully I'm not going to be creating too much anacrophobia here. So you're not wrong, Weasley from Harry Potter. But the spider does have a head and has a body, right? Consider this basically as the crawler of the spider. Each time you run the crawler to a different website, and of course, this is a low-key flex to watch Spider-Man No Way Home, in December, by the way, if you haven't seen the trailer. Very, very fire trailer, I have to say. So they have the website of each part of a spider. It's called a crawler because you're basically crawling towards each website, much like a spider crawling towards different website. It's very important to know exactly where you're crawling to. Just like you're carving the turkey, you have to know where you're carving the turkey. Or if you're making mashed potatoes, you have to know where the mashed potatoes come from. Or even the gravy, just putting gravy all over your cranberry sauce. There's a lot of organization to go on behind this particular type of coding. And I will not deny this. It's something I low-key attributed from other websites to show you that you can incorporate different people's code, but you have to understand what the heck they're doing or you'd be plagiarizing. And that is not good. And that's why I tend to not like people who copy code and don't understand it. Anyway, this also shows a great example of HTML that if you actually are successful with the web page, it'll be 200. If it's not, it'll just simply say it's not going to work. And I run a for each loop here. For each element, link on links on page. So where to get this element and document stuff from? I got it from this util, from JSoup, Java soup. Very similar to Beautiful Soup, it's meant to be a web crawler type of thing. And you have connection, JSoup, document, element, and elements. So this shows you right there a little bit OOP, a little bit of object-oriented programming going on here. So this is a really very, very well thought out finale. It not just teaches you algorithms and data science, it also teaches you great OOP and design. It's like the avatar, master of all 4 computer science theory, applications, systems, and software/design. It's like mastering all 4 computer science elements to wrap up the season. It's very, very impressive. Also even a try-catch. But this method I particularly like because you talk about Boolean. So once again, make a defensive coding. If word equals null, you cannot search any empty word. Otherwise, you keep on searching for the word until you actually search for it. And you basically return all the queued and number of links. So then just like how you try to test if the turkey is done before Thanksgiving dinner, how do you test the code, make sure this is well done, get the cooking joke, well done, before we're ready to serve this up to wrap up the season? You have something called test modules. And this is, once again, the power of unit TDD, test-driven development. So this is a very basic unit test that basically tests about empty crawler, basic crawler, number basic crawler, and of course, hash type basic crawler. So it tells you essentially all different types of crawlers. I'll actually run this test to show you that the thing compiles, but there's a small problem that I will actually address off screen. As you can see, I don't have the permission to run via Selenium. So this just shows this code is only here for demonstration purposes. It cannot actually run a web crawler without Selenium permission. So this gets into a little bit of an ethics conversation to wrap up the episode. So in general, when people use data and media and technology and everything, there could be disinformation problems. There could be some false news even. So I want you guys this Thanksgiving to be thankful that none of this algorithm intent content is creating any false news, any type of misconceptions. It's all about pure computer science, pure algorithms, and to quote Gail Lackman McDowell, also hitting on the soft skills, ethical skills as well. It's not just only passing the leak codes or passing the OAs, everything. Like getting into Dell made me realize now that like software engineering and even in general, engineering is much more than just passing the code. That's like a portion of it. What's more important is understanding how you understand your code and how you deliver it to another layperson. That's much more important. And that's the purpose of this entire season, is to tell you that, yeah, I could do great stuff on a whiteboard and teach you about dynamic programming, graphs, NP completeness, all the stuff I learned at Northeast and BU. But I really want you guys to learn is how to love yourselves when you're doing the code and how to basically learn to respect yourselves when the code is not working. Learn how to troubleshoot, how to fix things, not go wilding if there's like no point exception or, you know, profanities being thrown around because of some error. Like I want all of us to learn how to basically do coding and algorithms. So it's not something to be feared. It's not like something that people should fear in universities or even in industry or co-ops or what have you. That is something that should be appreciated. The reason why sometimes people don't like algorithms, including yours truly, is because it's not taught well. It's taught with the intent to pass the leak code, pass the OA, pass everything, do or die. Like under that type of pressure, just like trying to carve a turkey like a master chef, it's going to indefinitely cause you to cut your hand or do something crazy with the turkey or end up getting Gordon Ramsay roasted on TikTok. It's just not a fun way to do things. And in this economy, what's more important? To have fun in your career or to have fun and be successful in your career? Because remember, when you're doing your job, it's not just only for you, it's also for the customers. So make sure that when you give code, when you give design, give everything you do it with the mindset of the customer and with your clients. Because if you don't do that, things aren't going to go very well for you. So let me just stop the screen share and make some final remarks. This has been a very amazing, beautiful journey of Algos in 10 season 2 with Jason Liu. I think we learned so much. Even I myself learned a lot about where I started at Boston University undergrad 9th grade, not even able to learn how to use Java, all the way till now, a Dell Technologies engineer, already showing you basically how to use Java OOP at like a senior engineer level. So just to quote my boy, Nick White and Kevin Naughton Jr., who are more mature coders, or at least more, reasonable people in terms of like expectations and everything. It's not how fast you code or how much you want to pass. It's not like you're playing Fortnite doing OAs, or we're playing like, League of Legends doing like LeetCode, or doing CTCI, or doing any type of coding assessment. These companies want to evaluate how you handle the worst case without losing it. These companies want to evaluate how you are as a person in regards to coding. So this Thanksgiving, of course, enjoy your turkey, enjoy football, stay the heck away from politics, worldly religion, and COVID talk. And please, like and subscribe to this episode, and happy Thanksgiving. And of course, enjoy your Black Friday and stay safe during this time. So thank you very much, guys. It's been a great pleasure having this entire season with you guys. For August the 10 with Jason Liu, season 2. I think I've learned a lot, and actually there will not be a season 3 until late next year. But I am planning to do a certification for my Dell job, and I will be away for then. But in the meanwhile, I will still like upload YouTube stuff, for Christmas and even potentially for Thanksgiving. But until then, guys, stay safe, and honestly, learn to love yourselves. That's the most important thing you can do in this pandemic, and most important thing you'll ever do in any career, whether it be IT or nursing or whatever. Because if you love yourselves, the others will also learn to be thankful that you're having somebody teach you to love themselves. Like what my boy Benjamin Babish says, if you don't love yourself, then what's the purpose of doing the job? What's the purpose of all this? Especially in a pandemic, like what's the purpose of your life? So you have to first love what you're doing to have a passion for it. And if you have a passion for it, you gotta also learn to understand what you are doing. So yes, that is essentially it for this episode. Hopefully you guys can learn to stay safe during this time. If you have any questions, you can also DM my GitHub or do anything. Or keep on just roast my code, say this is complete BS and not like it. Whatever, I'm okay with open, constructive, non-trolling criticisms. We're here to all learn and have a positive environment towards computer science, algorithms, and Asian American software engineers. Thank you very much, guys, and have a nice Turkey Day weekend.